In lesson 42, we're estimating with scientific notation. In example 1, it just says estimate this product. What we're going to do is change each of these to scientific notation, and we're also going to round, in this case the tens digit, in this case the thousands digit, and in this case the tens digit is what we'll be rounding to. So this 16 between 10 and 20 is closer to 20, so that's going to be 2 times 10 to the first power. Then on 5,280, we're going to say that's 5 times 10 to the third power. And there's 2 more of those, so 5 times 10 to the third power, and another 5 times 10 to the third power. Okay, and then I'm going to have 12, and that is closer to 10 than 20, so I'm going to say 1 times 10 to the first power. And then that's another 1 times 10 to the first power, and then 1 more. There were 3 of those. 1 times 10 to the first power. Okay, now I'm just going to multiply the numbers together here. So this would be 5 cubed, which is 125, times 2, which would be 250, times 10. Then I will add all the exponents. So that would be, let's see, that would be 4, 7, 10, 11, 12, 13. Okay, and now I'll need to round to the hundreds digit. So that would be 3, and then I would move my decimal over 2 places, so that would be times 10 to the 15th. So that would be a rough estimate of what that product would be, 3 times 10 to the 15th. Now we can also use this for estimating whenever we're dividing numbers, okay? So we're just going to estimate by the first digit on each of those. So for the first one, that's going to be 4 times 10 to the third power multiplied by, that would be 5 times 10. Right now it's at negative 14. I need to go 1, 2, 3, 4, 5 places over. So I would add 5 because I was moving the decimal to the left. So that's going to be to the negative 9. Because I added 5 to the negative 14. Okay, then I need to estimate on bottom. So I'll say 3 times 10, let's see, it's 1, 2, 3, 4, 5 to the 5th power. And then over here, I'll have 7 times 10, and I'm moving the decimal this time to the right, so it's 1, 2, 3, 4, and it'd be a negative, so negative 5 minus 4 is a negative 9. Okay, now I can go ahead and multiply my numbers together, so I'd have 4 times 5 is 20, times 10 to the negative 6th power, and then 3 times 7 is 21, times 10 to the negative 4th power. And then I'll work this in 2 sections. So 20 over 21 is approximately 1. So I'll say that's just a 1. And then times 10, I would subtract the negative 4 from the negative 6, so it would be negative 2. Because subtracting a negative 4 is the same as adding a 4. So 1 times 10 to the negative 2nd would be the approximate answer for this problem. Alright, in our last example, we use scientific notation again to help estimate the answer to the problem given to us. So on the first one, I would move that over 2 places to the right. So it's 4 times 10. It's already to the negative 14th, and I need to subtract 2 more from that, so to the negative 16th. Then I'll estimate here, so that would be a 4 times 10, and let's look how many places I need to move. 1, 2, 3, 4. So that would be plus 4 to the exponent, so that would be 47. And then on bottom, this is going to be, because that's a 9, that would round up to a 10. So that'd be like 10,000 times 10 to the negative 23rd at this point. So that's going to be 1 times 10, and I'm going to move over 1, 2, 3, 4 places. So that's going to be plus 4, so it's to the negative 19th. Okay, then I'll go ahead and multiply my tops together. So I'll have 16 times 10, and then I'll add my negative 16 and my 47, so it'll be a 31. That's over 1 times 10 to the negative 19. Okay, so again, I work this in 2 steps. So 16 divided by 1 is still 16. And then I will subtract the negative 19 from the 31. So that'll give me a 50. And then I still need to round this. So that would be approximately 20 times 10 to the 50th, and then I would move my decimal over one place, so that would be 2 times 10 to the 51st. And that would be our approximate answer for this problem. Just be careful with those exponents. Make sure you pay attention to which direction you're moving the decimal. If you move it over to the left, you're going to be adding that number. If you move it to the right, you'll be subtracting that number. And then when you're dividing, you're subtracting whatever number is in the denominator. And I'm talking, when I say number, I'm talking about the power of the 10. You're subtracting that power of 10 from the power of the 10 that's in the numerator.